Elon Musk's chat with John Collison and Dwork didn't grab headlines because it was vague. People paid attention because it finally confirmed something robotics insiders have been whispering about for a while. The Tesla Optimus project just hit a major milestone. Version 3 isn't just a small upgrade, it's a leap forward. Musk said it himself. Optimus 3 is ready for mass production, in a way no other robot prototype ever was. And for the first time, Elon spelled out what Optimus will actually do in real life. Where it'll show up first, which problems it'll tackle, and, maybe most exciting, how we might start interacting with advanced humanoid robots much sooner than anyone thought. This isn't just hype, it's a real plan. Optimus 3 gets its public debut later this month. Tesla plans to show off at least 4 big upgrades that completely change the game for humanoid robots. There's a catch though, you won't be able to buy one until next year. The reason? Tesla's rolling this out way more carefully than anyone expected. When Optimus first made waves, people imagined it doing all sorts of complicated chores: cleaning, dishes, taking care of grandparents, maybe even making breakfast. Musk immediately pumped the brakes on those dreams. According to him, Optimus's first real-world jobs won't be the hardest ones. Instead, it'll start with simple, repetitive tasks that humans usually hate but robots can do all day long. And do well. That's a bigger deal than it sounds. So no, Optimus won't be folding laundry or babysitting right out of the gate. Instead, Tesla will put these robots to work in its own factories later this year. Factories are perfect for this. Everything's structured, every job is standardized, and managers can measure exactly how well Optimus performs. It's the ideal training ground. AI works best when it knows what to expect. And for a humanoid robot, the jump from prototype to ready for real work isn't about flashy moves. It's about doing this thing the same way, over and over, without screwing up. And honestly, there's no better place for that kind of testing than a gigafactory. Engineers can put Optimus on the assembly line, watch for mistakes, push safety limits, and fine-tune performance every day. They'll see in hard numbers how fast the robot works, how often it messes up, and how much more it gets done compared to humans. Here's the bit that really got people talking. Musk said that inside a gigafactory, Optimus Gen 3 could take on 10 to 20% of the work humans currently do. At first, that number doesn't sound world-changing. But take a closer look. Tesla's factories are some of the most efficient in the world. If a robot can steadily handle even a fifth of the tasks in a place like, that's a huge leap for automation. Not replacing people, but boosting what they can do. And that leads to one of the biggest things Elon clarified. Something that could totally change how people think about robots and jobs. For years, folks have worried. Robots will steal our jobs, people will get laid off, wages will drop, industries will flip upside down. Musk says that's not the plan. He was clear. Tesla doesn't plan to cut workers as Optimus rolls out. Actually, they expect to hire more people. Sounds a little backwards, right? But here's Tesla's logic. Robots aren't here to replace people, they make people more effective. Right now, a production engineer might run one assembly line. With Optimus, that same engineer could manage several lines at once since the robots take care of the repetitive stuff. Humans still handle problem-solving, creativity, and decisions, things robots just can't do. So no one's getting pushed out. Tesla wants to give its workers more power. With robots backing them up, each person gets way more done. Productivity goes up, wages can rise, and output grows. Most important, humans stay in charge, supervising, strategizing, and making the big calls. Musk is painting a future where robots help humans, not push them aside. That shift could change more than just Tesla. It could reshape the entire conversation about work, technology, and the economy. Another key part of Elon's big idea is this: Optimus robots eventually start building more of themselves. That's the dream. A factory full of robots making robots, pushing costs down fast as automation takes over the supply chain. It's the kind of feedback loop that can turn slow, clunky beginnings into wild, runaway growth. But not all robots are created equal. Elon didn't dodge the topic of cheaper humanoid robots coming out of China, like Unitree and others. Some with a sticker price as low as $6,000 to $13,000. Sounds like a steal, right? But Musk says the real difference isn't the price, it's what the robot can actually do. Optimus isn't just another robot on wheels. It's built to be truly humanoid, about 5'11", strong enough to carry weight for hours, and able to work long shifts without its actuators overheating. It's aiming for performance that competes with, or even beats, what a human worker can do. Sure, Optimus will cost more at first. But here's the thing, what you're really buying is flexibility and adaptability. A robot that can jump from one job to the next, not just repeat the same chore forever. That's how it delivers real value. Mass production only works if you've got the supply chain to back it up. Tesla's been quietly building that out, cutting deals with hundreds of Chinese suppliers, some involved since the earliest design phases. It's kind of like what Apple did with the iPhone supply chain, only now it's for robots. Final assembly for Optimus happens in the US. But a lot of the guts, thermal systems, actuators, sensors, power electronics still come from China. Right now, Chinese companies supply over 60% of the world's humanoid robot components. Try to cut them out completely, and the price of each Optimus jumps from $46,000 to more than $131,000. That's not just a bump, it's a wall. Tesla keeps saying the goal is to get the price down to about $20,000, something that'll take global scale, smart partnerships, non-stop engineering, and a supply network that runs like clockwork. Now here's where things get really interesting. The brains behind Optimus? That comes straight from Tesla's AI playbook. All those years of training self-driving cars, soaking up video, sensor readings, and real-world data, that's the foundation. Optimus builds on the same neural networks that power Tesla's self-driving software. Both the cars and Optimus work on a simple idea. Light comes in, and after a ton of processing, commands go out. A Tesla car chews through about 1.5 gigabytes of data every second. But in the end, it boils everything down to a few quick choices. Turn, speed up, slow down. For robots, it's even crazier. Instead of steering and braking, you have to control tons of joints, actuators, hands, and fingers all at once. That's exactly why Tesla obsessed over Optimus's hands. The human hand is a miracle of engineering, with dozens of moving parts and the ability to make tiny, precise adjustments without us even thinking about it. Musk says no one's nailed this in robotics. Not until now. Tesla's team had to design every piece from scratch because nothing off the shelf came close. Getting a robot to walk is one thing. Getting it to pick up a screwdriver, twist a cap, or thread a needle, that's the real magic. And to do that, you need a brain. Enter Tesla's AI, and now Grok. Elon says Grok will be the master controller, the brain behind the army of Optimus robots. Think of the robots as the hands and feet, and Grok as the manager running the whole show. Picture a new factory. Grok figures out the big picture, splits the work into thousands of smaller pieces, and tells each Optimus what to do. Some robots haul materials, others focus on assembly, and the whole system runs smarter and faster than any human team could manage. As the work progresses, Grok would dynamically reallocate resources, shift priorities, and continuously optimize workflows, much like a fleet commander, not a simple scheduler. This model, AI plans, robots execute, is what Tesla believes will form the foundation of future manufacturing. And it's not limited to factories. In logistics hubs, distribution centers, construction sites, renewable energy farms, agriculture, anywhere defined tasks are repetitive and structured, a Grok Optimus system could rewire entire industries. Still, Musk was candid that scaling Optimus production will not be easy. Unlike electric vehicles, where Tesla can pull from a broad catalog of commercially available parts, humanoid robots require highly specialized components that don't yet exist in volume. From actuators and power electronics to sensors and control boards, nearly everything has to be developed from first principles, designed from scratch rather than assembled from the existing market. For this reason, Elon compared the production curve to an S-curve, slow, painful growth in the beginning, followed by sharp acceleration after manufacturing bottlenecks are resolved. Early stages are expensive and inefficient. Later stages, once tooling, supply chain scale, and component reliability improve, could become orders of magnitude more efficient. And that's where the future gets exciting. Once Optimus units begin replicating themselves, helping manufacture other robots, production costs could fall dramatically, potentially hitting Tesla's ambitious $20,000 target. Think not just of robots in factories, but robots in warehouses, labs, construction zones, logistics centers, agriculture fields, retail environments, and eventually homes. But back to the near term. In the years to come, as Optimus evolves, we may see robots that help in healthcare settings, elder care environments, hazard zones, disaster sites, and even everyday households. But the rollout strategy, first in factories, then in institutional settings, and finally in broader society, reveals a pragmatic path grounded not in science fiction, but in operational efficiency. Musk's updates make one thing clear: humanoid robots are no longer a theoretical future. They are becoming an industrial reality with a defined deployment strategy, clear use cases, and a roadmap for scale. And while the initial phase focuses on optimizing industry and productivity, the long-term impact could be far more transformative, reshaping labor markets, redefining human-machine collaboration, and ushering in a new era of augmented productivity. To put it simply, Elon's Optimus Gen 3 is not just an evolutionary step. It is the first robot designed not for demonstration, but for real mass use. And that changes everything.